So I'm going to discuss chapter 2.3 number 21. In this exercise 5 to 24, find the inverse of the matrix if it exists. So in number 21 we have column 1. In column 1 we have 1, 3, 2, negative 1. Column 2 we have negative 2, negative 5, negative 5, and 4. In column 3, we have negative 1, negative 2, negative 2, and 4. In column 4, we have negative 2, negative 3, and negative 5, and 11. So we have the R1, R2, R3, and R4. To get the R1, we need to exchange it to the R3. So we have in row 1, we have 2, negative 5, negative 2, and negative 5. In row 2, we have 3, negative 5, negative 2, and negative 3. In row 3, we have positive 1, negative 2, negative 1, and negative 2. And in row 4, we have negative 1, positive 4, 4, and 11. So if what we have done in the right side, we need to do it in the left side. So we have 0, 0, 1, 0 in row 1, and in row 2 we have 0, 1, 0, 0, and in row 3 we have 1, 0, 0, 0, and in row 4 we have 0, 0, 0, and 1. After that, we have the R1. To get the R1, we have R1 minus R3. So R1 minus R3, and we get 1, negative 3, negative 1, and positive 3 in row 1. In row 2, we have 3, negative 5, negative 2, and negative 3. And in row 3, we have positive 1, negative 2, negative 1, and negative 2. And in row 4, we have negative 1, positive 4, positive 4, and 11. So in the other side, we have negative 1, 0, 1, 0 in row 1, 0, 1, 0, 0 in row 2, positive 1, 0, 0, 0 in row 3, and 0, 0, 0, 1 in row 4. To get the R3, we have R3 minus R4. And with that, we need to list down the R1, R2, and R4 and subtract R3 and R4. So we have 2, negative 6, negative 5, and negative 13. And in the other side, we have in the row 3, positive 3, positive 1, 0, 0, and negative 1. And then, to get the R4, we have R4 minus 2 times R1. So, R1 to R3 will still remain and R4 will be changed. And we get negative 3, 4, 4, 11 in R4. And in the other side, we get 2, 0, negative 2, and positive 1. And then, to get the R3, we have R3 plus R2. We need to list the R1, R2, and R4 and get the R3. And we have 5, negative 11, negative 7, negative 16 in R3. And in the other side, we have positive 1, 1, 0, and 1. And then, to get the R4 again, we have R4 minus 2 times R2. So, we list down the R1 to R2 and R3 and get the R4. And we have negative 9, positive 14, 8, and 17 in R4. And the other side, we have 2, negative 2, negative 2, and 1. And we need to exchange R3 and R4. So we have negative 9, 14, 8, and 17 in R3. And in R4, we have 5, negative 11, negative 7, and negative 16. On the other side, we have 2, negative 2, negative 2, and positive 1 in row 3. And in row 4, we have positive 1, positive 1, 0, and negative 1. After that, we have the row 4 again. So, to get row 4, we have R2 plus 2 times R1, R3. So, we need to list down the R1, R2, and R3. So, we get in the R4 is negative 15, 23, 14, and 31. In the other side, we get 5, negative 3, negative 6, and 1. So, to get the R2, we need to subtract the R2 and R3. So, we need to list down the R1, R3, and R4. And we get in R2 is 12, negative 19, positive, negative 10, and negative 20. In the other side, we have negative 2, positive 3, positive 2, and negative 1 in R2. So, our A inverse is equals to negative 1, 0, 1, 0 in row 1, and negative 2, 3, 2, negative 1 in row 2, and in row 3, we have 2, negative 2, negative 2, 1, and in row 4, we have 5, negative 3, negative 3, and 1, and it is invertible.